Good morning, all of you. In this session, we are going to discuss about spin-spin coupling. So this is the part of spectroscopy. In spectroscopy, various electromagnetic segments will be there. Among all the electromagnetic regions, lowest energy segment will be radio waves. By using radio waves, the spectroscopy which lays on this region will be nuclear magnetic resonance spectroscopy. NMR spectroscopy. In NMR spectroscopy, we will get a different kind of signals on delta scale based on the nature of hydrogens present in the given organic compounds. So those signals will be further splitted into different multiple signals. That is called spin multiplicity. Okay, spin multiplicity which arises due to spin-spin coupling within the organic molecule. So now we are going to discuss about the concept called spin-spin coupling in NMR spectroscopy. Let us define what is spin-spin coupling. Splitting of signals or spin multiplicity of the signals are arised mainly due to the neighboring protons present, adjacent protons present. Because of the adjacent protons, if the signals are splitting into various kinds, that process is called a spin-spin coupling. Appearance of multiplets of the peaks because of this spin-spin coupling, that is mainly due to neighboring protons present in the given compound. So all these transitions are merely possible in this radio frequency region. Magnetic spin of adjacent resonating nuclei. Because of spin of adjacent nuclei that will resonate with nucleus of observation, there is a splitting of signals are possible in the NMR chemical shift values. So spin-spin coupling leads to multiple peaks. Instead of a single peak, you may get singlet, doublet, triplet, quartet, quintet, multiplet. In this way, so many splitting of signals you can observe in NMR spectroscopy because of this spin-spin coupling. And mainly, signals doesn't rely on number of hydrogens, but depends upon nature of hydrogens present in the given compound. Now, let us apply the formula in order to predict the spin multiplicity because of spin-spin coupling. So here is the formula. Spin multiplicity is mainly arise due to the nature of neighboring protons, which can be calculated by using empirical formula, that is n+1. n+1 is the formula which uses signals will be appeared. Multiplets will be appeared for the given set of protons, where n stands for number of adjacent hydrogens which are present in the given compound. Let us explain the concept of spin-spin coupling by using this ethyl chloride. This ethyl chloride having two set of protons, set A and set B. Two set of protons are available in ethyl chloride, right? So let us apply this formula n+1 to two set of protons. Let us go with this proton set of A. For this, when we apply n+1 formula, adjacent the carbon having 3 protons, then the formula becomes 3+1. When 3+1 formula is applied, we will get the total number of signals 4. Total number of signals 4 stands for, this is called a quartet. Quartet is having the intensity of peaks in the ratio of 1:3:3:1. This is a bunch of 4 signals where the ratio is laying in 1:3:3:1 region. And this is mainly due to the presence of 3 neighboring protons. In the adjacent carbon atom, we have 3 neighboring protons, which can be influenced this one by the formula called n+1, so that we will get 4 signals here. 4 signals will be appeared for the given compound. So this is about set A. Now let us go with set B. For the set B, we are applying the formula called n+1. So neighboring protons are 2. 2+1, it becomes 3. So when 3 is the number of possible peaks at 3. So triplet will be appeared this, and peak intensity ratio will be 1:2:1. This is a peak intensity ratio. Being it is carbon having 2 hydrogens, here you will get triplet for B set of protons, quadruplet for A set of protons. This is for ethyl chloride. This is for ethyl chloride, right? So here is the spectrum given for ethyl chloride. You can observe triplet. Here, triplet is given for B set of proton, that is CH3. Here you can see 1, 2, 3 triplet in intensity ratio of 1:2:1. 1:2:1 ratio will be there for this methyl protons. Whereas A set of protons are getting the 4 peaks called a quadrat, and intensity ratio is 1:3:3:1. Here you can observe for CH2 protons, the signals are laying in between 3 to 4 ppm on the delta scale, and the intensity ratio will be 1:3:3:1. This is for CH2 protons. In this way, we can observe, we can explain spin-spin coupling. Because of neighboring proton, splitting of signals of this proton is observed, and which can be calculated by the formula called as one. For this ethyl chloride, you can observe signals in this splitting pattern, which is mainly predicted based on the spin-spin coupling. And what are the factors? What are the important influences which are given by various factors? Let us discuss all the factors influencing spin-spin coupling. Distance between the protons. Distance between adjacent protons is essential to determine the predicted spin-spin coupling. However, shorter distance between neighboring protons greater the extent of splitting. If distance between hydrogens are very small, it has a direct influence on the proton splitting, so that extent of spin-spin coupling will be more as the distance decreases. And next is about orientation. Spatial arrangement is called orientation around the carbon atom is considered in order to predict the spin-spin coupling. Hydrogen situated in the cis configuration means same direction if arrangement is there is a possibility of greater extent of spin-spin coupling. So when compared to trans inclination. So cis kind of orientation will provide highest extent of spin-spin coupling over trans inclination. And the next concept called the coupling constant J. And it is also another important parameter in order to get the valuable information about the structure of organic compounds. Coupling constant J is mainly defined as distance between the two adjacent peaks. When we are taking this quadrant, so in this quadrant, when consecutive peaks are present, this consecutive peak distance is considered as a coupling constant J. It is measured in terms of either hertz or cycles per second. So these are the units in order to express coupling constant values. Whenever multiplets of the signals are present, the peak distance between the two consecutive peaks is considered as a coupling constant J. It will give the information about bond distances and angles present in the given compound. In order to calculate coupling constant J, we have the formula delta value, which is obtained on the delta scale in ppm into frequency of the instrument. So at what frequency we are operating the instrument, so by using this, it is possible to calculate this parameter called a coupling constant. Now let us see. So this is about again ethyl chloride. Just now we saw one triplet and one quadrat will be given for the ethyl chloride on delta scale. When we observe the distance between two adjacent peaks, this is denoted as a coupling constant. And it is important to observe that whenever we are calculating the distance, it remains same for all peaks. Here also the distance remains same. Here also distance remains same for this given compound. And when we observe these three distances, they are exactly same. Hence it is called a coupling constant. The distance between the two consecutive peaks is called a coupling constant J. And why this J is important? What is the requirement of J? Now let us see what are the applications where we can impose the applications of these J values. When you take aliphatic compound, in this aliphatic compound, so hydrogens which are in the cis inclination, cis orientation, then J values are lying in the range of 6 to 8 hedges. If values in 6 to 8, you can identify the given compound is in sp3 hybridization. So for sp3 hybridized carbons, that means saturated carbon